Welcome to all. In this session, we will study program number 12 of C Programming Laboratory. Program number 12 is develop a program to find the square root of a given number n and execute for all possible inputs with appropriate messages. Now, we have to find the square root of a given number where we are not supposed to use any built-in function. In C programming language, it is possible to compute square root of a given number using a sqrt function. Likewise, it is also possible to find square root of a given number by means of pow function. So when we use these two functions, the program becomes very simple and we have to avoid. So that is what the problem statement. So definition of square root. We all know that the square root of a number s is usually denoted square root of s in this fashion, or else sometimes we can write in another way. It is like this: s to the power 0.5. There are many different procedures available in mathematics to find square root of a given number. There are methods like Babylonian method. There are methods like Newton-Raphson method, and many more other techniques are possible to find the square root of a given number. Now, arithmetically, it is possible to define this square root of a number in this fashion. It is a procedure to obtain a number from given number s, which when multiplied by itself yields s. For example, we'll consider a number 10, which is to find square root. Now square root of s, I mean by it is square root of 10. If I want to find square root of 10, I have to estimate or I have to predict two different numbers. When I multiply them, I should get answer 10. So now here is a number, that is 3.162278. It is multiplied by itself, possible to have value 10. So it is approximately equal to 10. So we are predicting a number which is multiplied by itself yields same number is nothing but the square root of that number. So where in this case you can observe that 3.162278 is a number which is multiplied by itself will give you 10. That's why 3.162278 is nothing but arithmetically proven square root of given number 10. Using predefined functions, it is possible to give solution to this problem. So here in this program, I have a built-in function pow. So pow function is possible to have there in a C program. The usage of pow function is like this: pow, P-O-W, then open parenthesis, then number. For example, if you want to find the square root of 10, you have to say 10 here in the place of num. So 10 comma 0.5, that means this is num is nothing but base, 0.5 is nothing but exponent. So when I write num comma 0.5 where inside pow function, it means that 10 to the power 0.5. 10 to the power 0.5, we know that already we computed using mathematically in this fashion. So this is nothing but the square root of that 10. Now here you can observe that one printf statement and one more the preprocessor directive statement hash include math.h is enough to obtain square root of given number. That means pow function is readily available to use where in C program. Other statements are common statement which are possible to have there in a program. So altogether you can see here in this solution 1, first line is nothing but the comment which begins with slash star, ends with the star slash. Whatever you write inside it is treated as the comment for the user. These are ignored by the compiler. Now next line we have it is hash include stdio.h. It is nothing but a preprocessor directive where stdio.h is nothing but a standard input output header file. It contains the definition and declaration for printf, scanf and one more printf what we use in this program. Now, so here in this case, one more header file, that is math.h, is included in this program. This line is included only to have a built-in function pow. This pow function is available there in math.h. As I mentioned, it will compute the square root of given number, where num is base, 0.5 is nothing but exponent. So if I say num is 10, then 10 to the power 0.5 is nothing but the square root of given number. What we observed here is 3.142278. Now when I execute, C program execution starts from function main. I declared a num here, and I gave a statement to the user to enter a number. Then using scanf, it will read a value from the keyboard. Then directly I am displaying a result, that is square root is equal to this percentage f depicts or this percentage f tells about the result pow. So here when you compute to 10 to the power 0.5, it will produce the answer 3.162278. So this is nothing but square root of 10. So when you execute this program with value 10, then you will get result, it is nothing but 3.162278. Remember here, float is a single precision number. That's why after decimal point you will have only 6 digit. Now beyond 6 digit is rounded to 6 digit, wherein the answer. One more solution using predefined function is here, where in this case instead of that previous program I use sqrt of num. Now sqrt is nothing but a built-in function which is to produce square root of given number. Here also the header file required for this predefined function is math.h. So here when you provide value num equal to 10, it computes the square root like earlier, but the function which is used where in this case is different than the previous one. This is also one more approach to find a solution for this problem, but these two are not preferred where according to the problem statement. He clearly mentioned that library functions are not supposed to use, but he failed to mention the function, that is pow function, to compute square root of given number. He just mentioned that library function sqrt is not allowed. Let us go through the algorithm to compute square root of a given number arithmetically. So here there are few steps mentioned in the algorithm. Initially we have to read a value for computation of square root. Then we have to predict. There are two parts, where in case of square root of any number there are two parts. If it is a perfect square, you will have only integer part of that number, and if it is a fractional part, then if there, let us consider number 4. When you find square root of this number 4, we will get the answer, it is 2. So it is a integer part. When there is a number perfect square, will provide you integer part only. If there is a number which is not having perfect square, then it may have fractional part in it. So to compute square root, now let me consider square root of 4. When you compute square root of 4, these 4 steps are enough to compute square root of 4, it is 2. And in case if I go for square root of 10, integer part is calculated by these 4 steps, that is 3, and real or the fractional part is possible to compute by these 4 steps. Now here in earlier example you can observe that the square root of the 10 is 3.162278. So where integer part is 3 and where fractional part is 0.162278. So to compute 3, we have first 3 steps, and to compute the fractional part, that is 0.162278, we have remaining 4 steps, that is 6, 7, 8, 9. So that's why I clearly mentioned here in the explanation of algorithm, step 2 to 5 are used to predict integer part of square root of given number. Similarly, steps 6 to 9 are used to predict square root of the given number. Then at the end, this integer part I and this integer fractional part f, both are added together to have the required square root. Now we'll trace this algorithm with some values. Now here I have first step to read a value for num. So I consider a value from the keyboard is nothing but 10. So my interest is here is to compute the square root of 10. So I have to go through step 2, 3, 4 and 5 are in a algorithm. So let me trace these 4 steps for integer part of square root 10. So now initially I have to do initialization. So initialization I equal to. So now in the process we have to predict which is that number is nearing to the square root 10. So you know that when you multiplied 1 with 1 result is 1. When you multiply 2 with 2 result is 2, 4, and 4 is not nearing to 10. So next when we multiply 3 with the 3 it is 9. So square root of 9 is nothing but 3. So I can say that it is 3 is square root of 9. Next 4 into 4 is nothing but 16. So you can see that square root of 16 is nothing but 4. Now square root of 3 is nothing, so 9 is nothing but 3. Square root of 16 is nothing but 4. So if I talk about square root of 10, if I talk about square root of 10, which lies in between square root of 9 and square root of 16. So in that process we have to predict that number which is that perfect square in between square root 9 and square root of 16. So for example, here in this case, let me start my prediction by initialing value of I equal to 1. I predict that at present initially the integer part of my computation for square root 10 is 1. So I equal to 1. Then I am checking multiplying I with itself whether it is less than number 10. So it is I into I is nothing but 1 into 1. 1 into 1 is nothing but 1. So whether 1 is less than 10, yes, condition is true. When 1 is less than 10, so condition is true. When condition is true, if yes, I equal to I plus 1, we have to increment value of I. So next, incrementing value of I by 1, so it becomes here in the process it is 2. I previous value of I is 1 and present value plus 1 is nothing but next value. So final answer for I equal to 2. So after making I equal to 2, go to step 3. Step 3 means again we have to check that condition. So here in this case, you know, now right now just we computed value of I, that is 2. 2 is multiplied by 2, that is 4. 4 whether it is less than 10, whether 4 is less than 10, true. So when condition true, again we have to increase value of I by 1. Previous value of I, it was 2. Now 2 is added by 1, it becomes 3. Then I have to do the computation of verifying the condition again. So what is that condition is, now you know that I is 3. 3 is multiplied by 3 itself, that is 9. 9 is less than 10. So 9 is less than 10. This condition also true. So when this condition is true, again we have to increase value of I by 1 more. So it is 3 plus 1. So it is 4. I becomes 4. Then go back to the step 3. Multiplying I with itself. It is 4 into 4 is less than equal to num. 4 into 4 is less than equal to num. That is 16. Whether 16 is less than 10, condition is false. When condition is false, we have to stop doing repetition of this verification increasing value by 1 and our prediction is over. We know that value of I, that is integer part, is whatever present integer value, it is minus 1 because present integer value is 4, which is not 4 into 4 is not less than 10. That's why we have to neglect it. What was previous one, which is less than square root 10, it is 9. Square root 9 means it is 3 into 3, it is 9. So 9 is less than 10. So we can predict clearly here, subtracting 1 from I, that is 4 minus 1 is equal to 3. So 3 is nothing but integer part of that this square root. So when I find square root of 10, in which integer part what we obtain is nothing but 3. So we got that 3. This is how integer part is computed. Now we have to proceed further with the real part. So in this real part we have to compute steps from 6 to 9. 6 to 9 where initially we predict the fractional part just having 3 digit after dot, it is dot 001. So we can go up to 6 digit also, but in this computation I considered only 3 digit, because when I do that computation of 6 digit, lot more steps are required. To avoid that, I went up to only 3 digit. We know that when we declare the float, the value will have single precision. That means a dot followed by 6 digit after the decimal point is possible. But where we considered only 3 digit after the decimal point, because only to reduce number of steps were in the process to make you to understand. So let us now trace 6, 7 and 8, 9 steps where in this process. We already got value of I, that is integer part of algorithm trace. It is nothing but I equal to 3. Now this is what our reference for all these calculations of fractional part. So in the process of identifying fractional part, initialize the f value. F is nothing but fractional part. The f value is nothing but f equal to 0.001. So I made initialization of f. It is what? Now soon after that we have to check I plus f into I plus f, whether it is less than num. So I is nothing but 3, which we got from previous 4 steps, 3, 2, 3, 4, 5. When we execute, we got final answer for integer part, it is I equal to 3. So that I is required. Now we have to predict the fractional part. Integer part prediction is over by step 2, 3, 4, 5. Now we have to predict fractional part by 6, 7, 8, 9. That's why I plus f. So I predicted, or I initialized the value of fractional part is 0.001. So when we add 3 plus 0.001, we get 3.001 is multiplied by itself. 3.001 multiplied by again 3.001 results, it is 9.006. Whether 9.006 is less than 10, yes, condition is true. So when condition is true, we have to increase value of f by 0.001, and we have to repeat that verification of the condition. So when we increment f by 1, adding 0.001 to the previous value, we got new value of f is nothing but 0.002. Now we have to add that f value with the I value. So we will get 3.002 multiplied by 3.002, whether it is less than 10. So 3.002 and 3.002, when we compute after multiplication, we'll get answer, it is 9.012. Is that less than 10? Yes, that also less than 10. Then again we have to add previous value of f, that is 0.002 by 0.001 to get the new value of f is that is 0.003. Now 3 plus 0.003 multiplied by 3 plus 0.003 will get 9.08, and which is again less than 10. Similarly, adding one more, it will get f equal to 0.004. We have to compute 3 plus 0.004 into 3 plus 0.004 to get answer, it is nothing but 9.24. In this fashion, we will proceed further for so many steps, where in the process we will get so many steps. And let us consider a situation now. We have the previous value of f is 0.161. It is added by 0.001. We have now 0.162. Now 3.162 into 3.162, when we multiply, we will get 9.998, which is again less than 10, or it is not equal to 10. Condition is true. Add this f value 0.61, 0.162 by 0.001, will get new value of f is nothing but 0.163. So this value is added with the 3, will get 3.163 multiplied by 3.163, which is definitely greater than, or it is not equal to 10. So condition is false. When condition is false, what was that f value? It was 0.13163, we have to reduce it by 0.001, because this is in the last step. We know that this fractional part, what we considered based upon fractional part we considered is 0.163, which is bigger than the required fractional part for 10. So that's why we have to subtract last step, that is from 0.163 we have to subtract 0.001. Then we'll get new value of that fractional part is nothing but 0.162. This 0.162 is added with the 3 will have the final square root of given value, it is 3.62. 3.162. So then we have to display this result and stop the procedure of finding square root. So finally I can say, by tracing this algorithm we are able to find square root of 10 is 3.162. Remember, we considered just 3 values after the decimal point, because in the process we'll have lot of digits to trace. To avoid that, I considered only 3 digit after the decimal point, but we can go up to 6 digit after the decimal point because of this program declaration, and we made a declaration where in the program it is float. Now here in this flow chart you can find the flow of this logic. Now initially we predict the integer part from 1. In case if 1 is not the required integer part of any number, we have to subtract it the end by 1 to make it 0, so that we can find the integer part of this computation. Similarly, now you can see this part here, this part, or this part is nothing but to compute the square root of integer part. And similarly this part you can observe here is nothing but it is used to compute uh, it is used to compute square root of fractional part. As I explained with the trace, we can go through this loop. Now here hexagon indicates we are using a for loop. In for loop there are 3 parts. So this is initialization part of for loop, and this is the control expression of for loop, and this is the incrementation part of for loop. Now very interesting here is this for loop is not having any statement to compute. So at the end of this for loop you find semicolon to indicate that this for loop is mainly used to count a value starting from I equal to 1. So where in this case you can see that I is 1 is the initialization of this looping variable, which starts from I, and it may go up to some extent to find the square root integer part of a square root number. Similarly, at the one more part you can observe here, it is the fractional part, where we are predicting only 3 digit after the decimal point in the square root. That's why we considered f equal to 0.001. If we want to go for 6 digit, go for dot followed by 5 zeros and followed by 1. It is to find square root of a number after decimal point. There may have 6 digit in the result. So here you can observe that the fractional part initialization we made, it is 0.001. So from this it will add step by step to reach the required square root of a number. Here in the process you know that just it is to count starting from f equal to 001, and it will go up to required level or required steps only based upon the condition what is there here in this. And at the end of this loop we'll have a value for f, that is subtracted by 0.001 to have exact fractional part of the square root. Then the I and f both are added together to have the required square root. Then we'll print it and then we'll halt it. Now here is a trace which is for number 16. Let me trace this where in a program explanation, and we'll see now what are the statements of this program. You can observe this program begins with hash include stdio.h. You know that hash include stdio.h is nothing but a preprocessor directive where we are including a header file, standard input output header file. This standard input output header file is included in this program because we have one printf here, then a scanf here, then followed by another printf, two printf and one scanf, then followed by we have here one more printf. So three printf and one scanf are there in this program. Because of these three printf and one scanf, we have the header file stdio.h. This is preprocessor directive which will replace definition for printf scanfs of this program, and soon after that these printf scanfs will have more number of lines from the header file. Once if it is done, this line preprocessor directive will be replaced by the compiler, or it will remove the compiler will remove this line only after replacing a proper definition for printfs and scanfs of the program. Now this preprocessor directive, we say hash include is nothing but an instruction to the compiler. It is not instruction to the processor. Now all those statements what we have inside this function main are considered as instruction to the processor. So C program execution starts from function main where we have local variable declarations, float num. So I want to find square root of a given number. So a number must be entered from the keyboard. So that is num. And at the end we will obtain square root of a number that is stored in sq root, and I is to hold the integer part of that square root, and j is to hold the fractional part of the square root, where everywhere we can have single precision number, that means a dot followed by six zeros, where in trace and other part I neglected most of that dot followed by six zeros which are not necessary in my explanation, so that's why I neglected them. So when I execute the statement, the computer will show you enter a number in the screen, and because of this backslash n, cursor will be focused to the new line. So in new line, you are going to enter a number from the keyboard is of type what float. We enclosed that it is percentage f in the quotation mark, to indicate that number is of type. You can see number is of type what float. So that's why here percentage f. Now ampersand because number reserved 4 bytes there in the memory for holding a value. That's why we have ampersand here. So whenever I type a number from the keyboard, it directly reaches where exactly it reserved space there in the computer memory. Now let us consider num equal to 16. Num equal to 16, where in case that given number is less than 0, in case the number is less than 0, right now it is 16. 16 is less than 0? No. So square root of 16 we have to find. We know that mathematically it is very easy to find square root of 16. Square root of 16 is nothing but 4, where in this case. But in case if I give a negative number, let me say it is minus 5. If I give minus 5 is less than equal to 0, condition becomes false, then it will show you the printf output there in the screen, no square root for given number. Why? Because if a number is negative, then it is not possible to find its square root. We believe that it is imaginary. But where in this case I am going to consider a value 16 to find square root. Now 16 is less than 0. If this condition is true, then it will execute this. Now 16 is less than 0, condition is false. When condition is false, it will jump to the else part of this program. So it will execute all these and then it will end the program. Now parallelly you can find the traces here in this box, and we'll go through one by one steps where in the process. Now we are going to start executing from else part line 1 till the last line. First line. So you can observe these two lines. These two lines are all together to find the square integer part of the square root. That's why I made a comment saying that finding integer part of square root. So now let me execute this line. We know that number is 16. When I execute this line, first it will execute initialization part of this for loop. So this for loop is initialized with the value of I equal to 1. So first it will do initialization, and it will do initialization only once. Thereafterwards it will repeat the other two part of this for loop. It is control expression. This is that control expression, and this is the control expression, and the next one, it is nothing but the incrementation of this loop. It is from here. So this is incrementation of this loop. So now initially it will execute this initialization part of this for loop only once. That is what here it is I equal to 1. That is what here it is I equal to 1. Now next what it will do, it will execute this statement. So when it executes this statement, here you can find where in the process I is nothing but 1. 1 is multiplied by itself, that is 1 is multiplied by itself is 1 into 1 is 1, whether it is less than equal to 16. So where 1 multiplied by 1 is nothing but 1, whether 1 is less than or equal to 16, condition is true. When condition is true, it will go back to executing that for loop again. So it won't go to next line, it will be there in this line only. Why? Because you can see here semicolon at the end of this line. So here when you put semicolon at the end of this line, it will do incrementation of this looping variable according to how exactly I is specified to increment. So here in this case I equal to I plus 1. So that is I plus plus. So I plus plus means whatever previous value of I. What is that previous value of I? Initial value it is 1. So 1 is incremented by 1 more. So it becomes now 2. 2 is multiplied by itself. It is 4. Is that 4 is less than 16? Less than or equal to 16? Yes, it is true. It is true means again increment value of I by 1 more. So it is 3. So this is incrementation part. So incrementation part is done. So I becomes now I equal to 3, and it will compute now 3 into 3 whether it is less than 16. 3 into 3 is 9. 9 is less than 16. Yes, condition is true. So it will increment the value of I by 1 more. It is I plus plus using this statement. So it becomes now I equal to 4, and 4 is multiplied by itself. It is what? 16 is less than 16. Is that condition is true? No, 16 is not less than 16, but 16 is equal to 16. Condition is still true. So next again it will increment value of I by 1 more in taking this statement. So it becomes now I equal to 5. When I equal to 5, condition to verify is nothing but 5 into 5 whether it is less than num. So what is that? It is 5 into 5, it is 25. Is that less than 16? No, 25 is not less than 16. Condition is false. At that time this line is skipped from the compilation. It will enter into this line. So when it enters into next line, whatever value of I, it is reduced by 1. I minus minus means I equal to I minus 1. So it is alternate statement for I equal to I minus 1, that is I minus minus. So you know that in the process we got last value of I is 5. Now that 5 is reduced by 1 is nothing but 4 in our answer. So we got the integer part of square root of 16 is nothing but 4. We do know that it is not having fractional part at all. But we'll trace this program further to find required answer. Now here you can observe the lines here onwards are to find real part of the square root. So in the real part of the square root again I have a for loop. In this for loop I predict real part initially by having initialization of this for loop. It is f equal to 0 0 1. So I can predict any other small value to have the fractional part of a number. Now here I predicted it is just 0.001 is the first step of predicting the fractional part of a square root, because I don't want to go for up to 6 digit. That's why I considered only 3. You may consider up to 6 digit also. So initialization is done. It is f equal to 0.001. Soon after that I have to verify the condition. So condition is nothing but I plus f into I plus f. This control expression I plus f. I we know that it is in the previous iteration we got it is 4. So 4 plus 0.001, 4 plus 0.001 into 4 plus 0.001, we got it is 16.008001, which is not less than 16. The condition is there itself is false. We have f equal to 0.001. We predicted the first fraction part of that square root of 16, saying that after 4 we have 0.001, but that condition itself is false here, indicates that you know that square root of 16 is nothing but 4. To have avoid the fraction, you can see when you verify after this computation whether that value 16.008001, whether it is less than equal to 16, condition is false, then we are going to reduce. Now after that this for loop is skipped from here, and f is reduced by 1. So when f is reduced by 1, so what was added to f was 0.001, it is subtracted soon, then becomes 0. So then the fractional part of f is 0. Then further to compute sq root I plus f, we have 4 as I, and f we have it is nothing but 0. So final answer square root of that given value 16 is 4 plus 0, that is 4. So you can see this sqrt equal to I plus f. It is to join integer part and fractional part of that square root to have a single value, where we got answer it is nothing but 4 after joining. Soon after that we are going to print the result. Here while printing you can observe it will print the square root of. Then what is this percentage 3f? Percentage 3f, practically speaking, here it will have 4 followed by 0 0 0 0 0 0. So 6 zeros it will have. But you can observe here in the process the fraction part is truncated by how many digits after decimal point? Point 3 digits, percentage 0.3f. Here also percentage 0.3f. So input is actually we considered 16, but internally it is stored with value, it is 6 zeros in this fashion. So you can see that this is input, we can see that this is output, but you can observe 16.6 zeros will be there and 4.6 zeros will be there. But here you consider a dot followed by 3 digits only after the decimal point for num. So then similarly here 0.3f for what? sqrt. So finally here in the process, if you try to have value in the case, it will print in this fashion. The result is like this. So it will print so let me type it here somewhere. Here it is this the square root of 0.3f. 0.3f means it is number, so number is nothing but 16, so it will have 16 followed by dot then 3 zeros. So here it is what? Then percentage 3f, it is nothing but 4.000 zeros. So it is what here. Then you can find what is that the slash n, it is to focus cursor to the new line. So I think it is clear. Percentage 0.3f to consider number, and percentage 0.3f to consider sqrt, and backslash n to have the cursor in the new line. So in the both cases you can observe that 16.6 zeros and 4.6 zeros, where in both cases 3 zeros are truncated, and it will show you answer in this fashion. It is the square root of 16.000 is 4.000. So this is how this program works, where in our execution you can compile this program in Turbo C compiler or in Linux platform using GCC compiler. So while executing in Turbo C compiler, there is a provision to look into the trace of given program. So or else I can say debugging is possible, where in case of Turbo C. So this is all about the program number 12 of C programming laboratory. Thanks one and all.